Torsion pendulum. Torsion pendulum consists of a heavy metal disc. Torsion pendulum. Torsion pendulum consists of a heavy metal disc which is suspended by means of a wire. When the disc is rotated in a horizontal plane so as to twist the wire, the various elements of the wire undergo shearing strain. The restoring couple of the wire tries to bring the wire back to the original position. Therefore, disc executes torsional oscillations about the mean position. Let theta be the angle of twist made by the wire and C be the couple per unit twist. Then the restoring couple per unit twist is equal to C into theta. Therefore, the angular acceleration produced by the restoring couple in the wire, which is denoted by A, is equal to d square theta divided by dt square. Let I be the moment of inertia of the wire about the axis. Therefore, we have I is equal to d square theta by dt square, which is equal to minus c theta. The above relation shows that the angular acceleration is proportional to angular displacement and is always directed towards the mean position. The negative sign indicates that the couple tends to decrease the twist on the wire. Therefore, the motion of the disc is always simple harmonic motion, and therefore the time period of oscillator is given by the relation T is equal to 2 pi into square root of displacement divided by acceleration. Substitute the values, we get T is equal to 2 pi into square root of theta. Acceleration is c by t into theta, gives us 2 pi into square root of I by c. Application of torsion pendulum. First one, determination of moment of inertia of an irregular body. Time period t1 of pendulum is determined by fixing a regular body at the free end of the torsion pendulum. Similarly, t2 is determined. If I1 and I2 are the moment of inertia of regular and irregular body respectively, then T1 will be equal to 2 pi into square root of I1 by C and T2 is equal to 2 pi into square root of I2 by C. Time period T2 is the time period for irregular body, T1 is for regular body. Taking ratio, T1 square divided by T2 square will be is equal to I2 by I1. The moment of inertia of the regular body about any axis can be determined by knowing its mass and dimensions. Thus, moment of inertia of the irregular body is calculated using the formula I2 is equal to I1 into T1 square divided by T2 square. Second one, determination of torsion rigidity or rigidity modulus. The time period of torsion pendulum is given by T is equal to 2 pi into I by C. Rearranging, C gives 4 pi square into I by T square, where I is the moment of inertia of the regular body and C is the couple per unit twist of the wire. But we know that C is equal to pi into N into R to the power 4 divided by 12. Substituting the value, we get N is equal to 8 pi L divided by R to the power 4 into I by T square. And we are using this formula in the lab. Bending of beams. A homogeneous body of uniform cross section whose length is large compared to its other dimension is called a beam. Neutral surface and neutral axis. Consider a uniform beam Mn whose one end is fixed at M. The beam can be thought of as made up of a number of parallel layers, and each layer in turn can be thought of as made up of a number of very small, thin, straight parallel longitudinal filaments or fibers arranged one closely next to the other in the plane of the layer. Neutral surface. It is that layer of a uniform beam which does not undergo any change in its dimensions when the beam is subjected to bending within its elastic limit. Neutral axis. It is a longitudinal line along which neutral surface is intercepted by any longitudinal plane considered in the plane of bending. When a uniform beam is bent, all its layers which are above the neutral surface undergo elongation, whereas those below the neutral surface are subjected to compression. As a result, the forces of reaction are called into play in the body of the beam, which develops an inward pull towards the fixed end for all the layers above the neutral surface and an outward push directed away from the fixed end for all layers below the neutral surface. These two groups of forces result in a restoring couple which balances the applied couple acting on the beam. The moment of restoring couple is called restoring moment, and the moment of the applied couple is called the bending moment. When the beam is in equilibrium, the bending moment and the restoring moments are equal. Different types of beams and their engineering application. There are 4 types of beams. Simple beam means a bar resting on supports at its ends. Continuous beam, a bar resting on more than 2 supports. Cantilever beam, a bar whose one end is fixed and the other end is free. Fixed beam, a bar fixed at its both ends. Applications of beams in fabrication of trolleyways, chassis, frame as track beds, elevators, construction of platforms and bridges, girgers in buildings and bridges.